Hey everybody, Chris here from Dummy Plug Conspiracy in what may be the final video of the series. I haven't decided yet, but I can't think of other topics that I can really fit into this format without becoming totally redundant with other stuff that's on the internet. So like we discussed before, if you want to learn more about soldering, about oscilloscopes, about electrical engineering in general, or about synthesizers in general, there's better resources out there. So we'll see. Today though, I want to talk about modifications and calibrations, which are two concepts you better get comfortable with if you're going to go down this road. Just because you follow the directions and just because you built it right doesn't mean your module is going to work right out of the gates. There might be things you have to tweak. At the very least, there might be things you have to tweak within the parameters of the design, but in some cases there's things about the design itself that aren't dead on right or not right for your purposes. So whether you're changing something because you have to or changing something because you want to, learning about modifying these modules is probably a good idea. Now, I only did a little bit of modification here and there where I kind of had to, so I'll talk briefly about that. We'll touch on VeroBoard and doing little prototyping projects as a way to add functionality that wasn't there. And then when it comes to calibration, we'll go out to the bench. I will take a module and purposely decalibrate it and then recalibrate it. I'm not going to go into crazy depth with that because there's a lot of different kinds of calibration, but we should at least look at it so that you're comfortable with it. The documentation on that stuff is generally really, really good, so I wouldn't expect somebody to get totally lost in that process, but we'll cover it anyway. Let's start with modification, and we'll talk about a couple specific things I had to do here on this synth. The first time I ran into modifications in a module was when I built my first ADSR envelope. And you probably know what these are already, but attack, decay, sustain, release envelopes are all sort of based on time. You turn the knob to determine how long that slope takes. And this board set, if you look at it, maybe I'll superimpose a picture, has two options. You can either set these for a really long range or a fairly short range. And the short range is, pretty normal and pretty usable. But if you wanted to give yourself huge attack and huge release, you can wire it differently. There's actually on the board set a long and a short, and you can wire to one or the other. So what I did, because I knew I was building, what did I got, 4 or 5 of these? I've got 5 of these. So I wired 2 of them to short and 3 of them to long, and I just leave mine that way because, it's fine for me. The other thing I could have done, though, is taken those 2 outputs, long and short, and wired them to a switch. And if I'd wired them to a switch, I could pick what I wanted at any given time. Now, I may still go back and do that someday, but I didn't do it at the time. However, even though those points are there on the circuit board, and even though I have the wire connected and it's curled up in there in case I ever want to go back to it, that constitutes a modification. And if you decide you want that functionality, you're going to have to drill that hole in the panel. You're going to have to buy and install that switch, and you're going to have to do that wiring. And it's not like it's hard, but it is an optional thing, and it does constitute a modification. So that's a pretty good, simple example of modifications, an optional modification. Now I'm going to show you one that wasn't optional. Actually, I'm going to show you 2. So the first time I ran into a modification that I really had to do was when I built my Music from Outer Space 16-step sequencers. Man, these things are cool, and I just love the way they turned out, and I had my metal shop build me these panels. This is one of the designs where I really just bought the components and did everything else myself, which was a bit of a scary proposition because these are so complex and it's a bigger build than anything I had done before. So everything was working. I was really surprised. I got this on the first try and it was working, and it was, the lights were cycling, everything was good. However, the next thing I did was bought a Moon Modular MIDI clock extractor, which basically takes MIDI clock from a sequencer and sends that clock and that start command out as conventional control voltage. Okay, pretty simple concept. You plug your start in and you plug your clock in, and this thing is supposed to just immediately respond to the MIDI clock instead of the internal clock. But it didn't. And I'm still not 100% sure I understand why the design is this way. I kind of forgot what the explanation was, and I'll put up some pictures here to talk about it. But ultimately I found out that there is a CMOS, or what they call a CMOS sensor behind this input. By the way, if anybody cares, CMOS is a complementary metal oxide semiconductor. And the whole point of that component is it can use fairly low voltage EM field effect to basically switch it from one status to another. It's effectively a switch that recognizes incoming voltage and says, oh, you don't want me to do this, you want me to do this. Right? That makes sense. So I found out, using my standards generator here, that input, for whatever reason, was about 3.5 volts low. I was doing the right thing, but this was looking for more voltage than I was putting into it in order to trip this over and switch to external clock. And I figured that out by taking that signal and turning it up 3.5 volts using this adjustment here. Okay, how do you fix that? Well, now you have to make a little Vero board prototype where you actually increase that voltage 3.5 volts. Pretty straightforward. And it has to be for not just the external clock input, but also the external start input, but they both had the same problem. We tried to do it the way nature intended, where you just plug and play. We couldn't make it work. I was working with a guy on the forums who was incredibly helpful, and we compared our designs and looked at all the different ways to do this. Ultimately, the only way we could get it to work, even though it was technically working, I could confirm that the voltage was right, and I could confirm that it could work, but it was causing other anomalies elsewhere in the module. The only way we could ultimately do it was by installing a switch that just switches between external clock and internal clock. Simple as that. But again, from a modification standpoint, I had to drill the hole, add the switch, label it, build the perf board project, stuff it back there, wire it in, test the heck out of it. The design was something we had to just kind of cook up, and that constitutes probably the most involved modification I have had to do so far. And I had to do it 3 times because I've got 3 of these sequencers, so at least I was able to kind of create an assembly line out of it once I knew that it worked. And that solved the problem, and everything's terrific now. And I actually kind of like having the switch there. It doesn't bother me at all that I couldn't do it without the switch. So that was shall we say, a modification success story, but it also was completely necessary. I couldn't have used this product right without it, and luckily everything worked out. So everything was going great, and I was coming very close to the end of my initial 5-cabinet build. The very last module I built was this 7-segment envelope generator, which is a super, super cool project. If you haven't checked this out, it's a Music from Outer Space module. It's awesome. Backtracking a little bit, remember I'm outputting plus minus 15 volt in my synth, and the reason I picked that is because I knew I was going to build all of the U-Synth modules, and those work on 15 volt. I knew I was going to build a lot of the Music from Outer Space modules, and those work on 12 or 15 volt. So I figured 15 volt is the safe place for me to be. Now, some of the Music from Outer Space modules require you to change something, usually just a resistor or something, in order to work in the 15 volt environment. Some of them work with no modifications whatsoever. Then I ran into this guy. The only one I found, shame on me for not researching this better, that only works on 12 volt. Won't work on 15 volt at all, and they basically, you're on your own if you want to make this thing work in a 15 volt environment. So I did, obviously, and I had to go down the road of developing a power modification board, which is essentially the same board you'd build for a power supply, except I didn't have to take the huge capacitors to step down, post-transformer power and squeeze it through a little 15 volt channel. I only had to build the voltage regulator part of that because I was really only regulating 15 volt to 12 volt. So it wasn't a super complex schematic. So I was like, you know what, I'm going to build this. So this is one of the failed attempts, if you can see that. This is a Vero board project, or perf board, some people call it, or prototyping board. Essentially, I built the circuit using this, and this is an uncut piece of perf board or Vero board. The concept here is pretty simple if you haven't seen this before. These are strips of continuity so that basically anything you solder over here is going to have continuity with everything along that whole strip, unless you go in with a Dremel tool and break it in the middle on purpose. And, you know, obviously I did some of that on here. But you can jumper around on this and essentially build whatever you need to build, but it's more simplified and a lot more coarse, and it's not, you know, commercially produced. It's not etched like a regular PCB would be. So anyhow, with this one, I did successfully finally build that power step-down board. I guess that's what we can call it. And it took 15 volt, turned it to 12 volt, and everything worked. The thing I ran into on this is that the transistors were really, really hard to pin out, because not all transistors pins are counted the same way, so it was very difficult to go find a manufacturer-specific schematic that told me exactly which way the transistors had to be in, and I was having a tough time with the pinout. But anyway, this one worked too, and I was off to the races, converting 15 volt to 12 volt, and that was really the one that took me the longest to get right. That was a few failed attempts, and it really had everything to do with those transistors. So that's a pretty good overview of modification, and I really just touched on some pretty simple examples. I mean, if you want to talk about one more, this is the EMS diode filter from Music from Outer Space, which is something that there are 1,000 modifications recommended for it. I don't know if any of them make this thing sound right. This is a weird one where after you attempt to modify it and you're sure you're doing something wrong and you're convinced that you can make this thing behave like a regular filter, eventually you read enough information on it and find out that it just doesn't work like a regular filter. It's a weird, bizarre project that no one really got 100% right, and modify this all day long, you're probably still not going to have exactly what you want. It's cool, you just got to go into it expecting it to overdrive and have a very, very narrow sweep, and there's certain things about it that are just weird, but no amount of modifying, and believe me, I tried, was going to make this thing sound like a normal filter, so that's okay. It's okay. Anyhow, that's an overview of modification. Next thing we'll talk about is calibration. I'm going to rip a module out of here. We'll go out to the bench and talk about that for a few minutes too. Okay, let's talk about calibrating a module. This is my little homage to George Takei. I called it the VCO My. And if you're a Sulu fan, you get the joke. I bet a lot of you out there are Star Trek fans, right? Just guessing. So right now, my bench supply is not outputting any current. Typically, you want to start this with current turned all the way down. Let's just turn current up. And when I hear that click over and complete the circuit, I'll know that this thing is running. So now this is powered up. Next thing I want to do is make sure it's making noise. I'm just going to plug into the ramp wave. Alright, sounds like a synthesizer to me. So I'll unplug that for the moment. And, you know, you'd be tempted to say, well, that works, and just go in the house and call it a day. Of course, it's not right yet. If you tried to play the thing, it would probably give you a lot of problems. So there's a couple things going on here. First of all, I will plug that back in. One of the things that we can trim, and hopefully you can see me doing this, this one right here is your initial frequency, or INIT frequency adjust. And essentially what you're doing here is just choosing what do you want to consider your sort of your lowest note. Because if I turn this thing all the way down, if you can hear that, I'm setting it super low, which for me is nice. Some people take a lot of time and make sure that when this is at its 12 o'clock setting, it's exactly A440. Yeah, sure, you could do that. I don't care so much about that personally. I just want to get a range that I can work with. And for me, where I've got it right now is pretty good. So I don't have to worry about that again at the moment. And this is one of the adjustments that you can make that won't really mess up any other adjustments. So I could always come back to it, is my point. Next thing I want to do is check the shape of my waveforms. So let's go to the triangle wave, which is going to be this one. And I'm going to take the probe from my oscilloscope and clip it on here. I don't really have to do ground, but I'm going to do it anyway.
Okay, so now, let's move that over. Okay, so I'm going to go over here and adjust the oscilloscope just a little bit, just to give me something a little bit nicer to work with. There. So now I can see that waveform pretty well, and I want to go in and adjust my bias on that waveform. So if I start to tweak that, you see it's getting all weird. Obviously that doesn't sound the same as this, right? And you could go both directions with it, but the idea is to get it to a point where it's right in the middle, as close as you can get it to a nice, balanced, dead-on centered bias setting. There. That's a healthy triangle wave. And the way these oscillators work, everything's based on the triangle wave. Triangle wave tends to be a nice, easy waveform to manage because it's equidistant point to point, peak to peak. You can go up and go down. You don't have to really massage that wave very much. And then you use that wave by running it through other series of this PCB to round it off and make it look like a sine wave, or adjust one side to make it look like a ramp wave, or adjust the other side to make it look like a sawtooth wave. Those things are going to kind of happen naturally once you've got this part right, with one important exception, and that is the sine wave. So if I go over here, let's make sure which one it is. All right, it's that one. These all have a shared ground, so I don't really have to move my ground when I move my probe. I'll make sure I get it in there so that it doesn't fall out. Here we go. Okay, so now we're looking at the sine wave. What I should have done was messed this up first so that you could watch me fix it. But I didn't think to do that, and it really doesn't matter. The point is, right now, the sine wave looks pretty good. I'm just looking for my sine trim. There it is. But it's possible that when I got in here, my sine could have looked like that. Or like, I could adjust it too far the other way. Or like that, where it's effectively just like a big, ugly triangle wave with a dip in the bottom. No, you don't want any of that. What we're doing right now is we're adjusting the resistance and we're smoothing the bottom and top of that waveform until it looks like a sine wave. And it'll sound like a sine wave. I'm just gonna, there. Sometimes it's nice to have different views of that. I'm gonna adjust my oscilloscope a little bit just to make sure I've got that as good as I can get it. Zoom in again. You know, you can go side to side with this a little bit if that helps. But to me, that looks pretty good. I'm just going to over crank it that way and then over crank it that way just to make absolutely sure I've got it in the middle where I want it. Boom. I think that's good. That to me looks like a sine wave, which means it's going to sound like a sine wave. And obviously, it's not hard for us to test whether it does. We can just go in here and plug it in, right? Well, there you go. I'm overdriving a little bit too. That sounded like it had a little bit of a peak on it, but it actually doesn't. So I'm pretty happy with that. So there you go. This is always a mix of using your ear and using your scope. And sometimes the ear wins and sometimes the scope wins. So just because you have perfect visual feedback, that doesn't mean you're going to want it like that necessarily. You got to listen a little bit too. So the next thing we're going to do here, and I can kind of disconnect the scope from this, but I think I'll just leave it on anyway. I'm going to take a lead from my standards generator. I have I think I showed you this in the bench video. You know, I have a generator that just goes from 0 volt to 7 volt and just cycles through it. And if I plug that in here into the control voltage input, that is going to kind of simulate having a keyboard connected to this, and it's going to cycle through 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3. You can see it happening on the scope, right? And that's increasing the frequency every time it makes one of those steps. So, you know, I just want to check and see if this works, A, but B, I want to use this to make sure that my scale temperament, I want to make sure that my lower C and my middle C are the same tuning. And that's one of the things that's going to take you the most time when you're tuning an oscillator. So let's actually listen to this. And again, I didn't mess it up before I. So there you go. So I'm going to let that run. And right now it sounds pretty good. I think what would be smart is for me to go manual with this instead. Now if I didn't think that that was good temperament, then I would go in and tweak the volt octave adjustment. And I'm going to plug in my tuner here. So everybody I think has seen one of these before. This is just your basic guitar tuner. Let's see if I can put it over here so you can see it. Alright, we turn that guy on. It's now telling us what note it hears. And right now we're set a little low. Okay, there we go. So it's telling us right now that it hears a D, but it's not a perfect D. So I'm just going to adjust this with the fine control to get a perfect D, or a near perfect D. There. That is a perfect D. Now if I adjust to the next octave, I should still have a perfect D. Well, it's close, but it's not perfect. So I'm going to go in here to my volt octave, and I'm going to tweak it. Now it might be counterintuitive that I'm tweaking it sharp, even though it came out flat. But that's the way temperament works. I'm trying to bring those note values closer together, if you can follow that logic. So I'm going to drop this down a little. I'm going to grab a different note. Let's say we just want to work with E. It doesn't really matter what note it is. The idea is the distance between the notes, not the notes themselves. So right now I've got a perfectly tuned E. Let's go to the next octave. Whoa! Looks like I need some more work. Alright, so I'm going to go lower again. Oscillators aren't perfect. You're going to have to just get it as close as you can. And a lot of times this can be frustrating, but trust me, you're never going to get it all the way perfect. Sometimes you just get it as close as you can so it's playable, and that's fine. Okay, so here I've got this thing pretty healthy. I'm using an A right now. Again, it doesn't matter the note, you just need to fix the space between the notes, but we're going to use A, so here we go. That's about as close as you can expect to get. I mean, that is really close. Certainly close enough to use it. Certainly close enough to play it. I think you'd be crazy to try and go a whole lot further than that with it. So so there you go. That's calibrating an oscillator. Not terribly complicated. Just sort of follow the instructions, listen to it. You could also do this sitting at a MIDI keyboard if you wanted to. If you just want to sit there, play the notes, and tweak it until it's perfect, you could do that too. The idea is exactly the same. Each octave you skip accommodates one full volt, because this is a linear system, not an algorithmic system. You've got 1 volt per octave, and if you tweak that and tweak that and tweak that, you're going to get it. So not rocket science, not a mystery, and I think the stuff with the waveforms is all pretty straightforward too. Now again, this is just one kind of calibration. There's all different kinds of calibrations. Sometimes you're not dealing with pitches at all. Sometimes you're just trying to, mute certain things in relation to other things. Sometimes it's mixer temperaments and different channels being equal to each other in volume, all that kind of stuff. But hopefully this gives you an idea what kind of adjustments you're going to have to do. There you go. That's calibration in a nutshell. A really simple example.
Well, like I said at the top, I believe this is the last video in the series. I think everything's been covered that I can do any justice to. If you disagree, if you want to see some other topic or subtopic covered in another video, drop me a line, put in a comment, throw something in the chat, and I'm happy to revisit this if people think there's value in doing another one. But look, in the meantime, you can do this. I'm not the smartest guy in the world. I came into this with a rudimentary knowledge of electronics, and a passion for synthesizers. And I think if you've got the passion part, you're 80% of the way there. Try it, you know? Try it. These aren't huge investments. If you do something wrong, who cares? Go back and fix it. You're going to learn something in the process, and that's never a bad thing. You're certainly never too old for that. So just let me know how it goes. Drop a line every so often. If you watch these videos, if you go and try this stuff, if you have success, if you have problems, if you want to correct me on something, I'm always interested to read that stuff. So I appreciate it. I'm glad you were here. And this is Chris from Dummy Plug Conspiracy, signing off.